So before we get into it, I'd like to share a guiding principle that I used when putting together this presentation, that this session is for visionaries. Now, I'm not going to make this out to be something grander than it really is, but for me, the fact of the matter is right in the title, Extending LookML Development. Who needs to extend LookML development? It's got a great IDE, real-time error validation, syntax highlighting. Well, somebody who sees the possibility for something more. And when you're talking about something more, it helps to know more than what, or where are we right now. So to start off, a bit of background. LookML development ostensibly began in 2012 with the launch of Looker, with its YAML-based, Git-backed modeling language. Fast forward 4 years later, in 2016, the Looker product had evolved, and it was time for a reboot of the LookML modeling language. We introduced what we called New LookML, and what we now refer to as just LookML. Even today, development continues. For example, this year we took the content validator out of beta. We currently have in beta LookML unit tests, which you may have heard about earlier today, and other minor features as well.
Right, hello everyone. So right from the beginning, Looker baked in developer best practices right from the get-go. So the core of this is LookML, but it's stored in Git. So these are like flat files, so they're plain text, they're human readable, they're structured, but they're exposed in Git. And then in the UI, you have like your inline validation. There's mechanisms for inheritance and reuse of code so you can keep it dry, so you don't repeat yourself. And then there's also a layer of abstraction. So Looker is essentially a SQL generator under the hood. Writing SQL, it's very error-prone, it gets very complex. That's where errors are introduced. But by having this abstraction layer and allowing developers to focus on entities and relationships and transformations and business questions and push the SQL generation down a level, that removes some of these sort of problems you get an error introduction. So you have the UI, you have the API. There's a bunch of great stuff that you can do in Looker. But what if it's not quite enough? What if you want to do a little bit more? Well, the fact that the code, the LookML files, are exposed in Git, which is outside the Looker tool, and they're in flat files, and it's versioned, but integrated with the tool, is essentially a backdoor. It's a backdoor into the application outside the API. And that's what a lot of these tools that we're going to review are sitting on top of that set of flat files in Git. So the goal of this session is essentially to do a state of the union, a review of all the different tools that have been open source in the last couple of years that are centered around LookML development and best practices around that. So we're going to review the different tools, what they do, where they work, and how tools are working and using each other.
As we were putting this together, we found that a number of categories naturally emerged. So we've created these 5 categories to help organize the projects we're going to be presenting today. The first category is parsers, or software to help take some raw LookML text or string and transform that into a more usable representation for other software to work with.
So the second category is generators. So imagine that you pass that LookML file. You have some JSON object representation. Now you can manipulate that and then write it back out to file. So that's the role of generators.
Our third category is visualizers and informational. So tools that help present an alternate view of your LookML project to help developers understand certain specific aspects of it.
Okay, the next category is linters. So if you have a style guide or a set of coding categories or rules, or you're looking for code smells, this is a role for linters.
And our next category, testing, goes one step beyond a linter. So whereas a linter is more of a static analysis of just LookML, a tester will bring that LookML into context with your instance or data so that you can test your LookML changes and your data changes in tandem.
Okay, and there's one other category, a sixth category of syntax highlighters, which we're not going to cover in this session, But this morning, we did publish a more detailed review of this in Medium, and I'll show you the link at the end that covers all of these, all the URLs for all the different repos that you can sort of dig into and read the documentation on these tools.
So let's get into our first category, parsers. As I mentioned, parsers help other software to work with a language. In that way, they're very foundational, so they're what we are going to cover first. And when it comes to LookML parsers, I'm really happy to share that as of today, there are 2 independently maintained, open source, and actively maintained projects for parsing LookML. The first one here on the left is one that I actually authored. I released it in 2017 and open sourced it in 2018. And it's a Node.js library. And the second one, which was released earlier this year, is for those of you who prefer to work in Python. And it was authored by Josh, who's also in the audience today. And so really, both of these parsers have a very similar output and can be used more or less with the same features. The main feature is going to really be what environment and language are you working in? Are you working in JavaScript and find a node module to be the most convenient thing, or Python? And if neither of those applies to you, actually both projects expose a command line interface, so you can parse your project and get the parsed results out as JSON and use it from any language.
OK, so our next category is generators. So here you are creating either new LookML files or taking an existing file and modifying it and writing it back out. So the first up is Josh Temple's LookML, you just heard about. So once you've read that, you pass the file, you have some JSON representation, Josh has added ability then to write that back out to file. So in that intermediate step, then you can mutate the data. So it allows you to parse it, mutate, and serialize it. Currently, there's no validation, so the best sort of workflow is to use it as from the parser, so it has the right, correct sort of internal representation, and then use it to write out. Next one is LookML Tools. This is authored by me, released earlier this year. And LookML Tools has 3 components. This is the first one, which is an updater. This actually takes a very different approach. And so this takes an existing file and can modify it, but it doesn't take an internal representation. I want to point out that it does use the LookML parser under the hood, so using other open source tools. Before that, it was using Fabio's node-based tool. So it's great to see some of these tools like using each other's work. OK, so I take a different approach, so I don't parse it, I just work from the file, and here's why. So here's my use case. So I have a data catalog that has this like source of truth for definitions of dimensions and metrics. And I want that to feed across to different BI tools. I don't want to like keep updating LookML and updating this other source, this other BI tool. I want to have one source and have it feed out to these different tools. So I have my definitions here, I have a mapping table from the definitions, the metric name, to a LookML file and dimension name. And then this tool will essentially like just compare the two. We'll take a LookML file and say, does this have dimensions that have a description? If not, I'm going to eject it from the source. Otherwise, I'm going to modify it. And then write it out to GitHub. And the reason why it works on the file is so that the GitHub PR has just the minimal changes. So just the descriptions changes. There's no other white space or formatting issues. So that when a human comes to review that PR, they just see the change, and that change is automated from all the way from the source of truth, so it makes it easy to review and approve the PR. OK, the next one is LookML Gen. So this is not quite as advanced, but it has the right structure. So you can create a view object, you can add in your dimensions, and then ask it to write out the LookML file. There's only a few kinds like fields and attributes, but the structure is all there to be able to extend it to make it much more rich and robust.
And actually, this category is the category that had the most software available for us, so we have a number of honorable mentions. This software is either not published, so it's just an article describing their code without the actual code, but still kind of instructive or illustrative for the first 2 articles, or actual software that's published with code, usable, runnable, not yet open sourced. as Carl alluded to earlier, we will have the links to all of these and more detailed write-ups in our blog post.
The next category is visualizers. So as your LookML repo grows, it can be hard to see the forest for the trees. You might have like dozens or hundreds of files. It's hard to see the general structure and relationships among the LookML files. So this category is going to provide some visualization about the structure of your repo as a whole. So this is LookML tools again. This is the second component, which is a grapher. So this creates a network diagram. So it's going to show you the relationship between models, explores, and views. And this is best explained with an example on the next slide. So here we have a simple graph. I just point to the tool at our repo. At the top, in these blue nodes, are the models. In the middle here, in green, are the explores. On the bottom here are the views. And so you can see the relationship between those. You can see code reuse. At the top, you can see there's an origin node. So that's a view that wasn't referenced by anything. It's an orphan node. And then, so that's a static view of the current state. Next slide. I thought it might be fun to see it over time. And so in the repo, you'll find code to be able to auto-generate this kind of animated GIF of the repo over time.
And the second project that we have in our visualizers and informational category was written by Joseph Exisa of Looker, and it is called Henry. It's a tool that helps you analyze your field definitions from your LookML in tandem with the usage data from your instance. This is particularly useful when you want to clean up unused views, fields, and explores. And it is a Python script that you can run on the command line and will show you reports on the command line. We also, in this category, have a couple of honorable mentions, which both of these have code available, but are not yet licensed. And do check out the blog post for the full write-up on each of these.
OK, so imagine now you've got your code, and you have some sort of coding standards. You want to apply that. So this is the job for Linters. So first up is Ryan Tux from Warby Parker's LookML lint. This, again, uses LKML under the hood as a parser. It has 9 rules. And so, for instance, they will look for a single view or primary key. Or it has ability actually to modify in some cases. So for instance, you might have an acronym, like USD for US dollars. Looker, when it creates those views in the UI, doesn't always do the right kind of camel case. This will actually be able to catch those and say, for these types of quantities, these types of currencies, we want that part of the name to be fully uppercase.
The next example here is a project that I co-authored, again, with Looker engineer Joseph Exisa. I'll take a brief aside, pun intended, to discuss the name, which is rather playful. So while we were working on this, I imagined linters to be very small, judgmental programs. So I named it Look at Me Sideways appropriately, or we call it LAMS, usually for short. It was a style guide first, so it actually includes a number of rules, 12 depending on how you count them, and we built the parser, the linter around that. In our case, we take the output of linting and actually put it back into your LookML project as a markdown file, so developers can get feedback right within the Looker IDE. And finally, we have a framework for specifying custom rules, which you can either write in JavaScript and host externally, or use a domain-specific language to write concise expression-based rules right within your LookML project. And while I have everyone's attention, I do want to share what is, for me, the most important aspect of our linter, and that is the out-of-the-box rule set. We really put a lot of effort into ensuring that the rule set reflects our experience working with hundreds of customer models and finding the common issues that customers run into. So our hope is, through these rules, we can provide to you solutions that you might otherwise have to figure out the hard way, if at all. And they come with very detailed documentation with rationales and lots of code examples.
So that's 2 linters. Here's a third. So I too have one. It's part of LookML's toolset. So this one has 10 rules. Although this morning, someone from Looker actually sent me an additional 7 to be folded into the repo. So mine apply a set of rules and write out essentially a report to CSV saying this rule, this dimension and this file failed or passed a certain rule, but it also writes to BigQuery. And if you write to BigQuery, you can put a looker model. If you put a looker model, you can put a dashboard. So I have this writing into BigQuery and have a look at dashboard so you can see which dimensions have failed or passed which rules. Next slide. So one of the things I tried to do is make it extensible as possible. So I use like abstract classes in Python to push as much boilerplate code up there as possible, very simple interface, so that by the time you write the individual rules, it's actually very simple. It just says if this is a dimension and if it doesn't have a description key, it's failed. Or if it has a description key, but the value is an empty string, it fails. So I kind of think of this in terms of like 3 types of rules. We have field level rules. So that's like a rule you could apply in one small chunk, one dimension, one measure. So for instance, like does the name start with yes, no, or is, if it's a yes, no dimension. Next is like file level rules. So you can only assess whether the rule passes or not when you look at the whole file. So does it have one view per file? And lastly, I call this other, but it's essentially a repository level rule saying, for instance, like no orphans. You can only look at that when you look at the whole set of files and repository to make sure that there are no references somewhere to that file. But yeah, saying like we have like simple interfaces, it's very extensible. Okay, next.
And our final category today is testers, which is perhaps should not be plural. But as a category, again, it is going one step beyond linting to actually allow you to check your LookML and your data together. We have one project in this category, again, authored by Josh in the audience and Dylan, I'm not sure if he's here today, Dylan Baker. It was a project between them, both of them, and it's designed to run in a CI pipeline, and it will query all explorers and fields to find errors relating to missing columns. They did a presentation on it earlier today, so if you weren't able to attend that, make sure to check out our recordings that will be published by our joint team after the conference.
Okay, so that essentially wraps up our State of the Union. So as you can see, there's many different tools covering different parts of the software development lifecycle. They're using each other, especially for the parsing. And it's a start of a very healthy ecosystem, something that didn't exist a couple of years ago. So it's really great to see.
So one way to contribute is by contributing to an existing project, and we really encourage everyone to try to get involved. For example, both of the parsers that I covered could really use help with better handling of comments or white space. Or the generators. There's a lot of the generators that are use case specific, so the EAV, for example, or the JSON to LookML, that perhaps they almost handle your use case. And if there were just one additional feature, they would handle it. So we encourage people to reach out to the maintainers of these projects, and if they're not open source, see if they could be open source, or if they are open source, to contribute to these existing projects.
Yeah, and don't forget, many of the authors are here either in the audience or just at the conference. So if you're interested, you can chat to them and find out and get involved. So I mentioned syntax highlighting is one other category that's covered in the blog post. Is there something else? Is there something that you're working on that is not covered here as another use case? So we want you to think about, is there a tool that you built in-house that someone else might be able to use and get some value out? If you're not sure, you can talk to your CTO or someone else. But try and get involved and give back, because it's once you start getting that, we all benefit, we all get value as that's as a network effect as this gets larger.
So the takeaway really is,
yeah, what will you share?
What will you share? And that concludes our presentation. We've left 10 minutes for questions and answers. We've also put the link to the blog post here. So yeah.